convolution, a mathematical operation on two functions that produces a third function that expresses how shape of one modified by another. So convolution of two real functions corresponds to multiplication of their respective functions. Let Laplace transform of f1 of t equals to capital F1 of s and Laplace transform of f2 of t equals to capital F2 of s. Now convolution is defined as the Laplace transform of f1 of t multiplied by f2 of t equals to f1 of s, f2 of s. The statement of this expression is known as convolution theorem. The word convolve means to revolve continuously. The two functions f1 of t and f2 of t are multiplied in such a manner that one is continuously moving with the time tau, let us say, relative to each other. That is, f1 of t multiplied by f2 of t is equals to 0 to t f1 t minus tau f2 tau of d tau. Now let Laplace transform of f1 of t multiplied by f2 of t equals to capital F of s. So f of s equals to integral 0 to infinity f1 of t multiplied by f2 of t of e power minus st dt. Now substitute this here, then you will be getting integral 0 to infinity that t equals to of integral tau equals to 0 to t f1 t minus tau f2 of tau d tau of e power minus st dt. Again, an unit step function u of t minus tau equals to 0 if t is less than tau or tau is greater than t. Thus, if we multiply the right hand side of the above expression by u of t minus tau, the product will be 0 for the values where tau is greater than t. The upper limit of the integration of the internal integral, that is of integral tau equals to 0 to t, can be changed to integral tau equals to 0 to infinity if the integral is multiplied by u t minus tau. Now let us rewrite the above expression. F of s equals to integral t0 to infinity of integral tau equals to infinity f1 t minus tau f2 of tau u of t minus tau of e power minus st d tau of dt. As the functions are Laplace transformable, f of s equals to integral tau 0 to infinity of integral t equals to 0 to infinity f of t minus tau f2 of tau u of t minus tau e power minus st dt of d tau. However, f2 of tau is not a function of t. So now we can write f of s equals to integral tau 0 to infinity f2 of tau of integral t to 0 infinity f1 t minus tau of u of t minus tau of e power minus st dt of d tau. But the inner integral is the transform of displacement time function, and this can be expressed as e power minus st of f1 of s. Now f of s will become integral tau 0 to infinity f2 of tau of this one equals to e power minus st f1 of s d tau. Now if you observe, other than this f1 of s, this is nothing but Laplace transform of f2 of s. Now we can write this as f of s equals to, take this out, f1 of s, the remaining term is equals to f2 of s. Hence the convolution theorem. This is regarding convolution theorem. If it is useful, please like, share and subscribe.